Hello friends, welcome to my video. In this video I will show you how you can design a differential equation in Simulink. It is very well known and famously said in a MATLAB and Simulink environment that whatever you can write in the form of an equation, you can design that in Simulink. I wanted to make this video since long time, and thanks to one of my audience who requested for this, and he also gave me the equation for to design that in Simulink. So this is the equation he has given. Although I won't have preferred this equation, it's a bit long one, but it's fine. We can proceed with this. So it's a second order differential equation for two variables, and we have to design that and with the initial condition of this. So in Simulink, to design any differential equation, the first thing you should do is the highest order of the equation should be on the left hand side, and rest all the elements or the sum or the elements of this equation should go on the right hand side. So basically if you rearrange these two equations, it becomes something like this. So basically we have to design in Simulink an equation which can perform these two things. Why you should do this, you will get to know when we start in Simulink. So but the highest order of differentiation should always be on the left hand side, and rest all should fall on the right hand side. So now let's start in our MATLAB environment to design this. So we'll create an Simulink model. Before we proceed, I'd just like to save this file. Differential equation Simulink. Yes. So I will go back to the equation. So in Simulink you must be knowing there is no differentiation block. So what we use is, instead of differentiation, we use the integrator block. So if it's a second order differential equation, we have to use two integrator block. So for both x and y, so we will have to use basically 2 into 2, so 4 integrator blocks. So we will add this integrator block here. So integrator of this one. So this will, and I'll just copy paste this over here. So this is the second one. Okay. So my first line, let's assume, is for x, and the second one is for y. So basically, if I connect these two, so say for example, if this is my x, so this becomes my x dot, because integration of x dot or x dx by dt becomes dx, and this becomes my d2x by dt square, which is basically the x double dot. So that's the reason why, if you understand that why we go for the highest order of the differentiation on the left hand side, because that is the way we do all the computation and not. So I hope you have understood this concept. So let's start now building our equation. So this will be for y. Also we can probably name this signal to make it a little more clear. X this, okay, and this one y this, yes. Okay, I will just zoom it so that you can see it nicely. So once we have done it, so first let's create our it doesn't matter, you can do anything. So let's first create our x double dot. So this is simple. What we have to do is we need a sum block which can sum all these four things, and then we need a gain block to do this -1 by 2. So first, so this is my x double dot. So to create that, first let's put a gain block here. So gain block, and it asks for what should be, so it should be minus 0.5. So if I connect this, and if you name this signal, so this becomes my x double dot, and just before this signal we should put a sum block. Okay, I will just go, and I prefer rectangle, so I'll just make. So we need 4. 1 2 3 4. We need 4 sum blocks here. 1 2 3 4 4 elements are there, one for each. So yes, and this comes here. So now we have to feed one by one all the elements of these four blocks. So first one is 2x dot. So this is my x dot. So multiply by 2. So we need a gain block here again. I will just quickly have a gain block with a gain of 2. I'll just flip it by using Control I, and this will go and connect to this first one, and this goes and gets connected to this X dot. Okay, that was, yes. The second one is 3 Y dot. So Y dot is here, so I again need a gain block. Probably I'll just copy paste this one, and not to waste. Or probably I can do one thing. I can just bring it here itself and flip it back and make it double click, make it 3, connect to the second one, and bring this port connection to Y dot. Yes, and the third one is, okay, I can have a X. So third is X, and so X is my this one. So this I can bring directly, like or probably I can connect it to I can bring it like this. It doesn't matter. Yes. Okay, I'll just leave it for the time being. Yes, so this third one is X, and this fourth one probably I'll go for 2Y. So my Y is probably I'll have to move a little bit this side, and my Y is this one, and that's multiplied by 2 times. So I will have again a gain block, and probably I can just have this one over here. Okay, and I give this input to here and this input to here. Yes, I can just bring it shorter. Yes, so my first equation is done here. So this is my X double dot. This is before, of course, X double dot, and this is my X. I can just name it also X. X. Yes. Okay, and this is my Y. So my X and Y is ready now. Now let's do this second equation. So for this again we'll need a sum block. I'll just quickly have a sum block here. So sum block, and I again go here, make it to rectangular, and this time please note we need one sum and 3 minus. So because if you go back, we need first one is plus and rest 3 are minus. So if I go back to the first equation, what you could have done is you could have also shifted this minus sign inside. Then in that case all this 4 plus would have become minus, and over here in the gain block you should have only put plus 0.5 and not minus 0.5. But since we are putting minus 0.5, it takes care of the sign over here. So over here this is my Y double dot. I'll just name it Y double dot, and the first equation sin pi t. So I just have sin. Okay, now here there is a catch. I will like to use this lookup tables sin pi t. But you can also use the other sign. I can show you before we move further. You can also use this sign. It was same, but why I am using this this lookup table sign pi t is to be inconsistent with what the equation says over here. So I just delete this, and as an input over here, it will be, instead of u, it will time t. So time t will be nothing but my simulation time, which I can get easily from my clock. But before I feed in this as an input, over here the equation is 2 pi u, and what I need is pi t. So I have to subtract, divide it by 2. So I just put a gain block with an gain of 0.5, and I just give this as a, so this becomes my first input for this Y double dot, and the other inputs which I need is X dot. So X dot will be nothing but this is my X dot, so I can bring this over here. Okay, so this is my X dot. My third input is 2 Y dot, so my Y dot is 2. Y dot is here, but there is nothing 2 Y dot, so I will have to probably put a multiplier. So what I can do is I can just quickly insert. Probably I can make this also a little bigger so that I get more space here, and so I put a gain block with a multiplication of 2. I will need is 2y. So my 2y, this is y and this is 2y, so I can just directly take this output over there. I know this has become a little bit messy, so you should be careful. This is not a good modeling practice, honestly speaking. We should be a bit more careful with the signals and where do we place what. But since in this tutorial I don't want to waste too much of time on that aspect. So I think more or less our second equation is also ready. So this is my second equation, the bottom one, and the top one is my first equation. Now we can run and see. I'm expecting some error to come up, and that's because I was expecting this to come up because it for the fixed point data type it uses the fixed point designer, and I don't have the license for that, of course. So if you have the license you can use it, but otherwise I will switch back to the double data type, which automatically just by this fix button it will do it. So just click fix and it's done. You should get this fix button. Now if I run it again, I am guessing it should work fine. Yeah, it worked fine. Now to see my output, let me put some scopes here, or I can put just one scope with probably a number of input ports. Probably I will need 4, one for x, one for y, one for x dash, one for y dash. So I just put 4, and so in my first port, first axis I will show x, second I will show the output y, what is my y. In third, let me show x double dot. Although it depends like what are the outputs you want to release and what are the, you can also use the two workspace block or log blocks to log the data in mat file, and all those things you can do simulate it into MATLAB. So once you have it, I will play it again, and I open this, and it should come up. Yeah, wow, see, so we have some graphs which is for x, y, x dash and y dash. So I think yellow is for x, blue is for y, and so on. To be a little bit more clear, what we can do is we can probably change it to this 4 axis, and yes, so now of course everything is of the same color, yellow. Yeah, so here the second one is y and this is x dash or y dash. If you see, it looks like a second order differential equation which is somehow slowly getting somewhere. It's oscillating. So let's increase the time frame to see what happens. So let's increase it to first 100 and see what happens. So if I simulate for 100, wow, see, so it's settling down at 0. So 0 must be the equilibrium point for my output y, and everything is settling down at 0. So you can collect this information from this graph, the settling time, the rising time, all those other parameters of the second order differential equation. Probably I will reduce it by something by half, 50, and see if my graph looks better. And yes, it looks much better. Now I can really get the data much more precise. Okay, so of course one more thing what I can do is probably if you are going to present this to someone, we can just copy this equation and put it in our model as an annotation. So I will just put this as an annotation. To change the line you have to just press shift enter. Okay, no, it didn't change. Yes, okay, so now it changed. So this is my okay, I just put one more differential equation. Yes, so now it looks like something good. I can present this to my colleagues or my peers, and they can use this as a second order differential equation. Okay, so I hope this video was useful to you. If you have any questions, please put in my comment section. If you like this video, please subscribe to my channel. Thank you for watching my video and have a nice day. Bye.